In this particular video, we're going to have a discussion on how to perform question to do with binomial expansion. And we're going to look at this question whereby you are supposed to find the coefficient of x squared in the expression of 2x minus 5 root 4 minus x. How are you supposed to do this particular question? This is a question that you'll be able to be tested when you are doing P3 papers. So basically this video is going to enable you know exactly what are the steps that you are expected to follow in order to work out such kind of questions. And if you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload further tutorials, you'll be notified. Let's dive in so that we can be able to see what are the steps required in order for you to do this particular question. Now let's begin by writing the question the way it is. We are told that we're supposed to find the coefficient, and whatever that we are finding the coefficient is actually given by 2x minus 5 Now, in order to work out this, the first thing that we're going to do first, we need to know what is the expansion of root 4 minus x. How can we be able to expand? So that's what we're going to do first. We need to expand this part. Once we have expanded the root of 4 minus x, then we're going to multiply it with 2x minus 5. So first we need to say root 4 minus x can be written as, we can be able to write this as 4 minus x raised to power a half, right? So which means that but for us to be able to use binomial theorem, we need the first term here to be actually 1. Yeah, so which means that we can be able to write this as further. I'll factor 4 out, so I'll say I'll factor 4 raised to a half out. I remain with 1 minus x raised to x over 4 then raised to a half. So when you are factoring this number that is inside out, you also take its power out, which will mean that this can be written as, this is the same as, we can say because 4 raised to a half is actually 2, the square root of 4, right? That is 2. So which means this is going to be given as 2 into bracket 1 minus x over 4 raised to 1 over 2. Now this is the part that actually we have at this given point that we are going to really try to expand. This part that we have here is the one that now we are going to expand using binomial theorem, right? So we can now conclude that this part of our equation is going to be given us, okay, we need to now say we can expand. This is the part that needs our expansion. This one here, this is the one that needs our expansion. Then we can now say our equation that we were having can be written as 2 into bracket 2x minus 5, then into bracket 1 minus 4 over 1 minus x over 4 raised to power 1 over 2. Okay, so we are going to ideally be working on this expansion now. What can this be expanded to? We are going to start by first looking at how does binomial expansion occur. So we are going to say, if you are having, according to binomial theorem, if you are having 1 plus x raised to power n, where n is a rational number, then we're going to say the expansion becomes, for instance, now we have 1 plus x raised to power n. This expansion becomes 1, right? We shall start by 1 plus xn, right? Then the next term will be nx. The next term will be plus n into n minus 1, right, over n factorial over 2 factorial, then x raised to power 2, right? Then the next term here will be n into n minus 1. Again, because we have done n minus 1, we are going to say now n minus 2 over 3 factorial x raised to power 3. And now the sequence continues like that. That is now according to binomial theorem. But now in our case here, then once we have the third term here, we shall say plus, the terms continues like that. So the next thing that we are going to do now is to simplify this expression that we have here. And we're going to say this is going to simplify to 1 plus, what is our n? Our n is a half times x. So this is going to be, because our x is negative 4, x over 4, because this value of x in our expansion here is negative x over 4, we're going to say this n times this, or x times n, we're going to get minus x over 8 at that point. But this one now, we're going to say this is going to be plus n. Our n is 1 over 2 into bracket 1 over 2 minus 1 over 2 factorial. 2 factorial is like 2 times 1. Then our x squared, our x is this, so we're going to say this is going to be minus x over 4 squared, and then the terms of the expansion continue like that. Because we are finding the coefficient, of x squared in this case, we are going to stop at that particular point, and then this is going to finally becomes 1 minus x over 8. Finally, this becomes 1 minus x over 8. Then if we work out this, we can see here is actually a negative. This one would be a positive, and if we simplify this, it will be a negative, so meaning this term also would be a negative. So if we simplify this, we're going to get our answer as x squared over 128, and the rest of the terms continues like that, right? So once we have this, we need now to go back to the expansion that we were supposed to do, because the part that we have done is this part in this given point. So meaning that we are going now to go back to the original expansion, because we know that this part here can be represented by this expansion. So we can see now this is going to be 2. Okay, our expansion was 2x minus 5. 2x minus 5. Let me just write it a little bit lower. This is 2x minus 5 square root of 4 minus x. This can be written as, we can be able to write this as 2x, 2 into 2x minus 5, and then 1 minus x over 4 raised to power a half. So already we have Now, because we know that this expansion here represents this part, we can now say this is going to be equal to 2 into 2x minus 5. But instead of writing this, we are going to write this part, which is actually 1 minus x over 8, then minus 1 x squared over 128, and the expansion continues like that. So once we have this, I'll try to reduce this upper part that we have here a little bit, so that we can say this is going to be 4x minus 10 into 1 minus x over 8 minus x squared over 128, then plus dot, like that. So we're going to see which part will we multiply in order to get to a coefficient of x squared. So I can see here comfortably that if I multiply 10 and this, I can be able to get a coefficient of x squared. So that is going to give us terms, you can say terms that gives x squared. Those are the terms that we are trying to look for, terms that will give us x squared. So if we multiply this, we are going to get here, this is negative and this is negative, so we're going to get 10x squared over 128. The next term that can give us a coefficient of x squared is actually 4x and x over 8, and this is going to give us negative 4x over 8, which is going to translate to a half. So which means that if we are looking at that, we are going to have what? So the next thing, we are going to factor x squared out so that we can be able to know what is the value of this. This is going to be 10 over 128 minus 4 over 8, and then we have x squared out. So if we work out this, we are going to get our answer being equivalent to negative 27 over 64 x squared. But in this question, we were told to write the coefficient of x squared. The coefficient of x squared is actually this part that we have here. So coefficient, therefore coefficient of x squared in the expansion is negative 27 over 64 as our final is negative 27 over 64. So that is basically what you are supposed to get in this particular question. The next question that will be asked in this kind of question is to state the set of values for x for which this expansion is valid. The set of values for x for which this expansion is valid. So in that case, you need to go back to the part that you did expansion. And the part that you did expansion is actually this part here. Yeah, this is where you expanded using the binomial formula. So once you identify this, you go and pick the value that you have there, and the value that we are going to pick is this value here, and this is going to be where this expansion is valid at where we have x over 4 negative modulus, or should be less than 1. So you're just picking this term, but remember, when we are talking of a modulus, it means we are going to take positive values only. So this is going to be x over 4 less than 1, which implies that this can be written as we can factor the 4 out, 1 over 4 out, and then we end up having 1 over 4 modulus of x. Because this 4 is a constant, then we are going to say is 1. Then you multiply by 4 both sides, because this is actually 1/4 times 4 both sides. We end up remaining having what? This is going to be, let me see whether I can have enough space to write here, because I want to be able to say this is going to give us x modulus is less than 4. Leave your answer like this: modulus of x less than 4, or at the same time you can be able to give your answer as x is greater than -4 or +4. So this is the range of values for x for which this expansion is going to be valid. Now suppose they change the gear and they tell you find the coefficient of x power 5 in the expansion of 1 plus x over root 1 minus 2x squared. What are you supposed to do in that particular question? You realize that we have this here, so we need to rearrange this. Of course, we need to rearrange this so that it can be able to become in a format that is nice. Yeah? So if we rearrange this, we are going to say our expansion that we are going to perform is actually 1 plus x into bracket, because this is over this, we are going to say it can be written as 1 minus 2x squared raised to power a half for the square root, but since it was a denominator, we are going to say -1/2 here. Okay, so meaning that we are going to perform this expansion first, so that once we get the answer, we are going to multiply with this term that we have at this given point. Then we can now say the expansion that we are talking about here, which is 1 minus 2x, yeah, raised, that is squared, raised to -1/2. We need to remember that in this case we said we are going to use the binomial theorem, and the binomial theorem, we say that is actually 1 plus x raised to power n is going to be given by the formula 1 plus nx plus n into n minus 1. Then we have x squared over 2 factorial, then plus dot dot dot. We continue like that. The series continues like that. So in that regard, let me just right now, for us to be able to work out this, we need to know what is the value of x and what's the value of n in this particular question. So according to this expansion that we are going to perform here, our n is -1/2, and our x, which we are going to substitute anywhere we have x in this part, is actually equal to, our x is -2x squared. So that is what we are going to substitute into the binomial theorem formula, right? So which means that we can now say our expansion 1 minus 2x squared raised to power -1/2, this one, we are going to perform in our expansion. We are going to do the first 3 terms first, because we know if we are going to do the first 3 terms, we'll be able to get the power x is to 5. So the first term will be 1. Yeah, the second term in our expansion should be n times x. Our n is a half, negative, and our x is this. So this is negative times a negative, we are going to get a positive, but this is a half and there's 2 here, we are going to get positive x squared, because a half and the 2 are going to cancel out. Then the next term will be n. Our n is 1 over 2 times n minus 1, negative 1 over 2 minus 1, right? And then we have x squared, but our x is this term that we have here, negative 2x squared. Then we are squaring the value of x, so we say squared at that point. And here we're going to say over 2 factorial. Those are the steps you need to follow. So the next thing that we must do at this point is to try to simplify this part here. We are going to say this is going to be 1 plus x squared. Let's see, what is this going to simplify to? We just try to use our calculator in order to simplify this term that we have here. Of course, we have negative a half times this, so this is going to be negative 1 over 2, which is multiplied to negative 1 over 2 minus 1. Right, at this point you can see you are having negative 2 here, which is going to be squared, so meaning that this term will be multiplied by positive 4, right? At that point we are going to multiply by 4, and the answer we get, we are going to divide by 2 factorial, and 2 factorial is actually 2 times 1, so we are going to divide by 2. So if I work out this, I'm getting my answer being equivalent to, you can see that this is equivalent to 3 over 2, right? So this term is going to translate to positive 3 over 2. So this term is going to translate to positive 3 over 2 x power 4, because this x was squared and then we squared it again, it becomes x power 4. So this is the expansion that was required for this particular part that we have here. Given point, I have to stop at this point, because if I'm looking for the next term here, if I'm trying to expand beyond this, I'm going to get the next term is going to be x squared raised to power 3, and x raised to power 3 is going to give us power 6, and we are not interested with power 6 at that given point. So meaning that I need only to simplify this. If I simplify this, I'm going to have 1 plus x squared, and then if I work out this, I'm going to get plus 3 over 2, right? And if I work out this, I can see this is actually a half negative, and this is going to be a negative value inside here. So negative times a negative will be a positive. This one is going to be a positive, so this is going to reduce to 3 over 2 x raised to power 4. Then our expansion for this part is this. Now, because we are working out this so that we can be able to multiply this guy here with this expansion that we have, we are going to say this is going to translate to 1 plus x into bracket and our expansion is actually 1 plus x squared, then plus 3 over 2 x power 4, and the expansion continue like that. So once you have done this, you're going to realize that we need to find x raised to power 5. How will you get x raised to power 5? You'll only get x raised to power 5 if you multiply this term and this term, right? That's what you'll do in order to get the x power 5. So meaning that coefficient coefficient of x power 5 is going to be obtained from this, and this is going to be 3 over 2. Yeah, this is the coefficient of x squared, right? The next question that automatically will come after this is for you to state the range of values for this expansion is valid. And we say that you are going to check the part that is expanded using binomials is actually this part here. So we are going to say this is going to be modulus of negative 2x squared, like that, right? So which means what? Should be less than 1. And we can, because we are talking about positive modulus, positive values, we can write this as 2x squared modulus less than 1, which means that we can say this is going to be 2 modulus of x squared is less than 1. So which implies that modulus of x squared, yeah, is going to be basically less than 1 over 2 in that case. So which means we can say this is a modulus. You can be able to say this is a values of x, right? Modulus of square root of 1 over 2, right? How can we be able to write this again? We can be able to say, if you want to make examiner happy, you can say it's less than 1 over root 2. Yeah, so those are different ways you can be able to say that. And also you can even say this is x is greater than negative 1 over root 2, less than 1 over root 2. So we can be able to leave our answer in that particular format. And if you have gotten value from Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. The next tutorial is coming up, so stick and watch, and ensure that you are sharing this particular channel to all your friends and classmates.